Right, so the video cut off at the end. We weren't quite done. So we found the formula for the slope, which is 2x, and then they want to know what is the slope at the point -1, 2 and the point 2, 5. So what you're going to do is take your formula and plug in your x values. So we take 2x, we plug in -1, and we get the slope of -2 at that point. And then we plug in 2 for the x value, and we get 4 for the slope at that point. So that would be the end of example 5. In example 5, we saw that we made a formula for the slope and then we plugged in those points. And so that formula for the slope is what we call the derivative of the function. And so we found the formula of the slope using that limit process. And so when you do that formula, you're actually finding the derivative. So derivative is called many different things. We have been calling it the slope of the tangent line. We've called it now the formula for the slope of the tangent line, and now we're going to call it the derivative, and the notation for a derivative is f prime of x. So f of x, if there's no little apostrophe, is your original function, but if there is this little mark, then we're talking about the derivative, which is the slope of the tangent line. So in example 6, they ask for the derivative, but it's the same thing we've been doing on the past few examples. So we're going to have limit as h approaches 0 of this function, and we plug in x plus h minus the function itself all over h. Again, I'm just following this formula here. So here I'm going to need to FOIL this, distribute the 3, distribute the -2, and distribute the negative. So I've got the limit as h approaches 0. I'm going to have 3. I'm going to FOIL this x plus h, which is x squared, 2xh, h squared. Distribute my -2. Distribute this negative all over h. Then I'm going to distribute the 3. So I have 3x squared, 6xh, 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. And then we get to cancel stuff. So 3x squared cancels with -3x squared. And 2x cancels with -2x. And everything else, it isn't the same. So we're going to have those, but they all have an h in them. So we can factor an h out of everything that's left. And that's going to leave me with 6x and a 3h and a -2, which then helps me cancel the h's. And then I've got this function left, and we can plug in our limit. So we plug in 0 for h, and that leaves me with a 6x minus 2, and that is your f prime of x, or your derivative of the function. So this is a formula for the slope. If I want to know the slope of this parabola at any point, I can just plug in an x value and tell you what the slope is there. We're going to do the same thing in example 7. So they're giving you the function square root x, and then they're asking you to find the slope at 2 points. So we first start by finding f prime, which is the limit as h approaches 0 of square root x plus h minus square root x all over h, following that limit formula at the top of the page. Now here, there's nothing really to simplify, but we can't get 0 in the denominator, so we're going to have to multiply by the conjugate. So the conjugate of the top is radical x plus h plus radical x. And we got to do that to the top and the bottom so that the fraction is balanced. And so on top, I FOIL this, and I get radical x plus h times radical x plus h is x plus h. Then radical x plus h plus that is, you can just write it like this. Those two multiply together. Then you've got negative rad x times rad x plus h. And then you've got negative radical x times radical x, which is just negative x, because the radicals will cancel. And on the bottom, don't distribute. It's just a waste of your time. You want to leave those two things separate. Otherwise, you're going to have to do a little bit more work later. Then we're going to collect like terms. Our middle terms always cancel when we do the conjugate. And so we're left with x plus h minus x. So also these x's are going to cancel. And all I have then left is the h on top. So I've got h over h radical x plus rad x. The h's now cancel and give me 1. So 1 over rad x plus h plus rad x. And now I can plug in my limit and not get 0 on the bottom. So I'm going to get radical x plus 0. And then I still have that other radical x, which makes 1 over 2 radical x. So this is f prime of x. Now to find my slope at 1, 1, we're going to take f prime and plug in 1. So 1 over 2 radical 1, and that's going to give me 1/2. And then I'm going to find the slope at 4, 2. So that means I'm plugging 4 into my derivative. And that's going to give me 1 over 2 times 2, or 1/4.